Alright guys, thank you for coming to the meeting today. Close your lab please.
So last week our sensors were a success and they were all looking good. Good job, guys.
Alright, with this in mind, with the sensors that we did, if they're all working, how are we going to be able to use these to do our main mission of getting to the poles and getting our ice and bringing it back?
So I think that it's important we work on programming the robot. This is a really nice one. We have to make sure it can go forward, backwards, and on side to side. And it has these specialized gears that I think they all have like a motor in it that will actually make it just be able to move like this, as well as programming it to be able to go in a square motion like this. It's critical, as well as also being able to just rotate on its own like this. We can achieve this by making these two rotate in opposite directions, and it would go like that.
Alright, perfect. I think basic movements are really important to make sure that we can do the bigger tasks. So when we're working on navigating the terrain, that's going to be very important, but how will we be able to navigate the terrain using our sensors?
Yeah, so we have multiple sensors located on the sides and on the front. And if it just like wants to go somewhere and it sees it get too close, or it detects danger, maybe there's like a pit or something, it will just stop there and do whatever it must do to be safe.
Alright, Theo, as we continue our mission, like as we're getting to the poles, how can we?
So for our robot, the one robot's going to have an ultrasonic distance sensor on the front to make sure that when it's driving and there's like a big rock in the way, it'll move and it'll be able to navigate around the rock and make sure that they can get to the poles without getting injured or destroyed. And then we'll have a second rover that's following it. It'll have a temperature and moisture sensor on it that will be able to read underground and tell when there's water or ice that we can extract and melt at our plants. And they'll communicate with each other wirelessly, and the data will be stored in the robots themselves and at the plant.
Okay, perfect. So when we get to those locations that have the most ice, we obviously need to extract it, but first we need to cut it to be able to get to it. So Sydney, do you know how we could cut it?
Okay, so for our third week project, we will be using robots to focus on the precision and control of cutting the Martian ice. The first robot will be equipped with either some sort of drill or like a laser cutting schematic. That will also have a temperature sensor on like the front that will help to be able to detect the temperature of the ice to make sure it doesn't accidentally melt or crack, ensuring that we can efficiently extract the ice. The second robot will be following and will help measure and align the cuts so that we can most accurately and efficiently transport the ice to our facility.
Alright, so you mentioned transport, Jackson. Do you know how on the way back that would work? Because I know we have like extra ice and it's more weight now. So how would we do the movement back to the plant?
Yeah, of course. So on our final week, we would have one robot with an arm to be able to lift up the ice balls and put them onto the other rover. This other rover would also have an ultrasonic distance sensor on the front to avoid objects on the way back to the plant, and a temperature sensor inside of it to maintain a good temperature of the ice inside.
So by combining all of our 4 functions, or our 4 sensors, we can implement them on the actual rover to make sure everything goes smoothly, and we can extract, explore, and transport all our materials on Mars to make sure our mission meets the quality of our consumers and that everything will flow smoothly.
Alright guys, thank you for coming to the progress meeting. We'll start this next week.